Caleb has a message that he wishes to send. So we have the message in the bottom right of the screen at the moment. Caleb's going to use his private key to encrypt a value, but the value that he's going to encrypt is based on the data that is to be sent. So this is our hash value. So Caleb calculates a hash value. In this case, we're going to say that Caleb's calculated the value 376. It then gets encrypted using Caleb's private key. The next thing to happen then is that the encrypted data, which is the signature, along with the original data that has to be sent, is then encrypted using Nicole's public key. Again, that's the key that everybody has access to. So it's now encrypted and therefore it is secure. Caleb now sends that data to Nicole. Now you'll notice that the data is received by everybody. That's not because Caleb sends it to everybody. That's by nature of the way that the internet functions. The internet sends data everywhere across the network in order for it to reach its intended destination. When the data is received by Nicole, she's able to deal with it, but the data is also being received by lots of other nodes along the network, including Jamie. Nicole is able to open the data to decrypt it using her private key. When she decrypts it using her private key, she gets the signature, which is encrypted, and she gets the data. Now, nobody else on the network, even though they've received the data, nobody else can decrypt it because nobody else has access to Nicole's private key. Nicole then uses Caleb's private key to decrypt the signature. And when she decrypts the signature, she finds that there is a hash value of 376. She can then recalculate the hash value based on the data that's been transmitted, works out that the hash value should be 376, and accepts the data as having not been compromised. So successful communication. Nobody else on the network is able to access the data that has been transmitted. So I know what you're thinking. You're thinking, well, what if Jamie adds to Caleb's message? Because Jamie has Caleb's public key and has Nicole's public key. So what he could do is he could add a little bit of a message and he could encrypt it using Nicole's public key and just add it to a message that's been sent. Okay, so let's imagine that Jamie wishes to add some lies into the message. So he has a message that Caleb sent. He knows that it's been authenticated by Caleb, and so he decides to add information to it, and then he's going to send it on to Nicole. So he adds them into the box, and the box gets a little bit fatter. He then decides to transmit that across the network. Again, it's being transmitted across the network and everybody's receiving it. So when Caleb receives it, for example, he's not able to decrypt it because he doesn't have Nicole's private key. And Nicole's private key is required in order to decrypt the message in the first place. Nicole, however, does have Nicole's private key. So Nicole decrypts the message. And the message contains the digital signature. It contains the original message from Caleb. And it contains the additional data that was added to it by Jamie. The next thing that Nicole does is she decrypts the digital signature. And when she decrypts the digital signature, she finds that the hash value is 376. She recalculates that hash value, but when she recalculates the hash value, she incorporates Jamie's data into the result. So if it was a simple calculation with number of files, for example, the answer should be 376. Now it's 377, which doesn't match. And because it doesn't match, Nicole knows that the data cannot be trusted because the data has been compromised. And that ensures the authenticity of data communication across the network.